This is PL-300, Star Schema and Relationships. 10 exam-style questions, 10 seconds on each. Every answer checked against Microsoft Learn before recording. Where the question bank is wrong, I say so. By the end, you will read a relationship correctly in both directions, name it the way the exam names it, and know the two valid designs for analyzing sales by several dates. 1. Read cardinality and direction from the grain and name a relationship active, single direction, many to one. 2. Name the 4-dimension types the exam tests, role-playing, junk, degenerate, and type 2 SCD. 3. Solve the multiple dates problem 2 ways, role-playing tables or inactive relationships plus user relationship. 10 questions. Cardinality and direction, dimension types, the grain of a fact table, cross-filtering with security, and the multiple dates problem. Question 1 of 10, before the relationship exists. You need to create the required relationship for an executive's visual joining the sales table to a region table on RegionID. Sales region ID is currently typed as text. Region ID is a whole number. What should you do before you can create the relationship? Your options. A. Change the data type of sales region ID to whole number. B. Change the data type of sales region ID to decimal number. C. In the sales table, add a measure for sum sales amount. D. Change the data type of sales ID to text. 10 seconds. The answer is A. Change the data type of sales region ID to whole number. Both sides of a relationship must be a compatible data type. Region ID is a whole number, so sales region ID has to become 1 too. Until then, Power BI simply refuses to create the relationship. Why the others fail? Decimal number would still mismatch a whole number key, and an ID has no fractional part anyway. A measure aggregates values. It plays no part in defining a relationship. Sales ID is not the join column. One more thing, mismatched types are the most common reason a relationship silently will not form. Verified against Learn Microsoft.com create and manage relationships in Power BI desktop. Types matched, now which way the relationship actually points. Question 2 of 10, which way does it point? You build a report to analyze customer transactions. The database contains a customer table where each customer appears once and a transaction table where each customer can appear many times. You import the tables. Which relationship should you use to link them? Your options. A. One-to-many from transaction to customer. B. One-to-one between customer and transaction. C. Many-to-many between customer and transaction. D. One-to-many from customer to transaction. 10 seconds. The answer is D. One-to-many from customer to transaction. The one side is the table where the key is unique, which is customer. The many side is transaction. So the relationship runs one-to-many from customer to transaction and filters flow from the dimension down into the fact. Why the others fail? Reversing it to transaction to customer describes the same physical link the wrong way round and is not how Power BI expresses it. One-to-one would require each customer to have exactly one transaction. Many-to-many is for genuinely non-unique keys on both sides and brings a performance cost you do not need here. Verified against Learn Microsoft.com model relationships in Power BI Star Schema guidance. Direction follows the grain, next saying it the way the exam says it. Question 3 of 10, naming the relationship precisely. You have a semantic model with 2 tables named dim customer and fact order details. The primary key of dim customer is customer ID. Fact order details contains a customer ID column, and multiple rows in fact order details can share the same customer ID. Which type of relationship should you create from fact order details to dim customer? Your options. A. An active, single direction, many-to-one relationship. B. An inactive, single-direction, one-to-many relationship. C. An active, single-direction, one-to-many relationship. D. An active, bidirectional, many-to-one relationship. 10 seconds. The answer is A. An active, single-direction, many-to-one relationship. Read the direction from the table you start at. From the fact to the dimension is many-to-one. It should be active so it filters by default, and single direction so filters travel from dimension to fact only. That is the standard star schema relationship. Why the others fail? One-to-many would be correct only if you described it starting from dim customer. Inactive means it does nothing until a measure invokes it with user relationship. Bidirectional invites ambiguous filter paths and hurts performance. Use it only when you have a specific reason. Verified against Learn Microsoft.com model relationships in Power BI. 3 parts named precisely, now which of them is fastest? Question 4 of 10, cardinality for speed. You have a semantic model containing fact sales and dim product. You need to define a relationship from fact sales to dim product. The solution must ensure the fastest DAX query performance. Which cardinality should you use? Your options: A. One-to-many. B. One-to-one. C. Many-to-many. D. Many-to-one. 10 seconds. The answer is D. Many-to-one. Starting at fact sales, the relationship to dim product is many-to-one, and that is also the fastest option. The engine can rely on a unique key on the one side so it does not have to resolve duplicates at query time. Why the others fail? Many-to-many forces the engine to build an intermediate result on every query and is the slowest choice. One-to-one requires uniqueness on both sides, which a fact table does not have. One-to-many is the same relationship described from the other end, not the direction the question asks for. Verified against Learn Microsoft.com relationships with a many-many cardinality star schema guidance. Many-to-one wins on speed. Next, the vocabulary the exam tests by name. Question 5 of 10, naming the dimension type. You have a semantic model where a single table named dim address is joined to the fact table more than once as the billing address and once as the shipping address. Which type of dimension is represented by dim address? Your options: A. Type 2 slowly changing dimension SCD. B. Junk dimension. C. Role-playing dimension. D. Degenerate dimension. 10 seconds. The answer is C. Role-playing dimension. One dimension table serving several distinct roles against the same fact, billing versus shipping or order date versus ship date, is a role-playing dimension. The signature in the diagram is multiple relationships from one dimension to one fact. Why the others fail? A Type 2 SCD tracks history with effective dates and surrogate keys per version. A junk dimension bundles unrelated low cardinality flags into one table to avoid many tiny dimensions. A degenerate dimension is an attribute like an order number that lives in the fact table with no dimension of its own. One more thing, learn all 4. The exam tests dimension vocabulary directly, not just how to build relationships. Verified against Learn Microsoft.com star schema and the importance for Power BI. 4 dimension types learned, now getting the fact table's grain right. Question 6 of 10, getting the fact grain right. You are building a report using data from an Azure SQL database. You import orders, order line items, and products. You need to analyze orders sold over time with a measure of total order value and orders by attributes of the products sold. The solution must minimize update times. What should you do? Your options: A. From Power Query, merge the order line items query and the products query. B. Create a calculated column that adds a list of product categories to the orders table. C. Calculate the count of orders per product by using a DAX function. D. From Power Query, merge the orders query and the order line items query. 10 seconds. The answer is D. From Power Query, merge the orders query and the order line items query. Order value lives at line item grain while order date lives on the header. Merging orders into order line items produces a single fact table at line item grain carrying both, which lets products stay a clean dimension related to it. Why the others fail? Merging products into the line items collapses a dimension into the fact, losing the star shape and bloating the table. A calculated column holding a list of categories is not queryable as an attribute. A DAX count does not solve the structural problem of two tables at different grains. Verified against Learn Microsoft.com star schema guidance merge queries overview. Grain settled, next the same problem at 30 million rows. Question 7 of 10, 30 million impressions. You have an impressions table with approximately 30 million records per month, plus ads and sites tables. You need to build ad analytics that present impression counts by day, campaign, and site name while keeping the model performant. Which two actions should you perform? Each correct answer presents part of the solution. This one wants two answers, not one. Your options. A. Create one-to-many relationships between the tables. B. Group the impressions query in Power Query by added, site name, and impression date. C. Create a calculated table that contains added, site name, and impression date. D. Create a calculated measure that aggregates by using the count rows function. 10 seconds. The answers are A. Create one-to-many relationships between the tables. B. Group the impressions query in Power Query by added, site name, and impression date. Reporting only needs counts by day, campaign, and site, so group the impressions up to that grain in Power Query and 30 million rows become a fraction of that. Then relate the summarized fact to its dimensions one-to-many for a proper star. Why the others fail? A calculated table is created after the raw data is already loaded, so the model still carries all 30 million rows. A count rows measure computes the number but does nothing to reduce what has to be scanned. One more thing, summarize at the source or in Power Query. Anything done in DAX happens after the rows are already in memory. Verified against Learn Microsoft.com data reduction techniques for import modeling. Summarized at the source, now which columns to keep and which to drop. Question 8 of 10, hide or delete. You are creating an analytics report from two related tables. The employee table contains employee ID and employee photo. Employee ID is used by the relationship between the tables. There are no reporting requirements on either employee ID or employee photo. You need to optimize the data model. What should you do with each column? Two selections here. Employee ID. Choices are hide, delete, rename. Employee photo. Choices are hide, delete, rename. 10 seconds. The answers are hide and delete. Employee ID is doing structural work, the relationship depends on it, so it must stay in the model, but hiding it keeps it out of the field list where report authors would misuse it. Employee photo does nothing at all, so delete it and recover the space. Why the others fail? Deleting employee ID would break the relationship. Hiding employee photo leaves a heavy binary column in the model, costing size for no benefit. Renaming changes a label and optimizes nothing. One more thing, hide what the model needs but user should not see. delete what nothing needs. Verified against learn Microsoft, COM data reduction techniques hide fields in report view. Hide what the model needs, delete what nothing needs. Next, relationships plus security. Question 9 of 10, cross-filtering with RLS. In Power BI Desktop, you are building a sales report containing two tables. Both tables have row-level security configured. You need to create a relationship between the tables. The solution must ensure that bidirectional cross-filtering honors the RLS settings. What should you do? Your options. A. Create an inactive relationship between the tables and select Apply Security Filter in both directions. B. Create an active relationship between the tables and select Apply Security Filter in both directions. C. Create an inactive relationship between the tables and select Assume Referential Integrity. D. Create an active relationship between the tables and select Assume Referential Integrity. 10 seconds. The answer is B. Create an active relationship between the tables and select Apply Security Filter in both directions. The relationship has to be active to filter anything at all. Then Apply Security Filter in both directions is the specific setting that makes RLS travel along a bidirectional relationship instead of leaking data past it. Why the others fail? An inactive relationship does nothing until a measure invokes it, so RLS has no path to follow. Assume Referential Integrity is a direct query optimization that lets the engine use inner joins. It has no bearing on security. Verified against learn Microsoft, COM row-level security guidance bidirectional cross-filtering. Security travels the relationship, now the problem that needs two designs. Question 10 of 10, sales by 3 different dates. Repeated scenario series. A report imports a date table and a sales table. The sales table has 3 date foreign keys: due date, order date, and delivery date. You need to support analysis of sales over time based on all of the date foreign keys. For each proposed solution, does it meet the goal? For each statement, yes if it is true, otherwise no. Statement 1, for each date foreign key, add inactive relationships between the sales table and the date table. Statement 2, from Power Query Editor, rename the date query as due date, then reference it twice to create order date and delivery date tables. Statement 3, from the Fields pane, rename the date table as due date, then create order date and delivery date tables by copying it. Statement 4, create measures that use the user relationship function to filter sales on the active relationship. Statement 5, from the Fields pane, rename the date table as due date, then use a DAX expression to create active relationships for the other 2 dates. Statement 6, create measures that use the user relationship function to filter sales on the inactive relationships. 10 seconds. The answers are Statement 1 no, Statement 2 yes, Statement 3 no, Statement 4 no, Statement 5 no, Statement 6 yes. Only 2 approaches work. Reference the date query in Power Query to build 3 role-playing date tables, each with its own active relationship. Or keep 1 date table with inactive relationships and write user relationship measures. Why the others fail? Inactive relationships alone do nothing until a measure activates them, and copying a table in the Fields pane is not how you create one. User relationship against the active relationship is pointless, and Power BI allows only 1 active relationship between 2 tables. One more thing, 2 valid designs: role-playing date tables or inactive relationships plus user relationship. Verified against learn Microsoft, COM user relationship function active versus inactive relationships role-playing dimensions. 6 things to carry into the exam. 1. Types must match. A relationship will not form across incompatible data types. Fix the type first. 2. Many side is the fact. 1 row per customer, many rows per transaction. Direction follows the grain. 3. Many to one is the fast one. Fact to dimension, single direction. Avoid many to many unless forced. 4. Know your dimension types. Role-playing, junk, degenerate, and type 2 SCD each have a signature in the diagram. 5. Bidirectional plus RLS turn on apply security filter in both directions or the filter leaks. 6. 1 active relationship only. Extra dates need role-playing tables or user relationship measures. That is episode 6. Episode 7 is date tables and time intelligence. Mark as date table, auto date time, role-playing dates, and the time intelligence functions. This series runs 20 episodes and covers the whole exam. Subscribe so you get each one as it lands. And tell me in the comments which question caught you out. I read them all. See you in episode 7.